Happy New Year, everyone. Today we will start looking into how to solve linear programming problems or LPPs. This is a very useful and practical video series, so please subscribe to my channel and watch this and all upcoming videos on this topic. A programming problem is a problem having an objective which is to be fulfilled under certain constraints. An example of a programming problem is a furniture factory problem that manufactures chairs and tables. The objective here is to develop a production plan to maximize the total revenue while considering the available resources. And we are given the selling prices of a unit of chair and table, units of wood and hours of labor available. Also, how much wood and labor is required to produce a chair or a table. The moment we convert this objective and the corresponding constraints into a mathematical expression and represent these by mathematical equations or inequalities, the problem is called a mathematical programming problem. As we can see, mathematical programming problems are optimization problems in which we try to maximize or minimize a numerical function of variables under some constraints. When the mathematical expressions and inequalities are linear in form, that is, we cannot have powers of x1 and x2 or their product in these expressions, then the mathematical programming problem is called a linear programming problem. This is how we can write any general LPP with n variables and m linear constraints. We have the linear objective function which we try to minimize or maximize, and we have some equality or inequality constraints to satisfy. Let's review some of the key elements of a basic LLP. Decision variables are unknown quantities that are expected to be estimated as an output of the LPP solution. In the furniture factory problem, there were two decision variables, chairs and tables. Objective function is a numerical value representing profit, cost, production quantity, and so on, which is used to evaluate the amount by which each decision variable would contribute to the net present value of an activity. In the furniture factory problem, we wanted to maximize the total revenue from the furniture production. Constraints are the restrictions or limitations on the total amount of a particular resource required to carry out the activity that would decide the level of achievement in the decision variables. In the furniture factory problem, we had limited units of wood and labor hours. Non-negative constraints are where each decision variable in any LP model must be positive irrespective of whether the objective function is to maximize or minimize the net present value of an activity. For a successful formulation of an LP model, we need to follow these steps. That is, we need to understand the problem, identify the decision variables involved in the problem, identify the various coefficients of the objective function, identify the various restrictions of the problem, represent the objective function in the form of linear expressions involving decision variables, and finally represent all the restrictions in the form of linear expressions involving decision variables. Let's look at an example and formulate the corresponding LP model. In this case, we have a small plant that manufactures two models of a product, say A and B. Two resources R1 and R2 are required for the manufacturing of units of this product. One unit of A consumes 10 units of R1 and 15 units of R2. Similarly, one unit of B consumes 12 units of R1 and 17 units of R2. The company has 800 units of R1 and 600 units of R2 available per week. Each unit of model A and B gives a profit of $50 and $70 respectively. Find the optimal weekly production levels for these two models. So the first step was to read through this information and understand the problem. So in this case, we want to find the optimal weekly production levels for the two product models. Next, we want to identify the decision variables, which in this case are the two product models A and B. Next, we need to identify the coefficient of objective functions, which are extracted from the profit statements of each unit of models A and B. Next, we need to identify the restrictions of the problem. And finally, we want to write the mathematical expressions in linear form for both the objective function and the constraints. In the next video, we will use graphical method to solve the LPP with two decision variables. I hope you liked this video. Thanks for watching and see you all in the next video.